All right. So
I'm going to talk about a reduced form advantage in spoken word recognition. Let me just get this out of the way a bit. And let me start by realizing that usually in cognitive processing, practice makes perfect. We see that in deliberate training, like the classic study of Erickson on the training of digit span, but you also see this in passive exposure, like in the word frequency effect. Words that we hear very often are more easily recognized than words we don't hear that often. Now, there is one surprising counterexample to that. That is the canonical form advantage. So if you look at words like center in American English, there is a 90% likelihood are likely to produce something like center. However, in lexical decisions, so in perception, center usually is recognized better, that is with higher accuracy and shorter latency than center. Now, Birke et al. Had already asked, is this a canonical form advantage, myth or reality? And one issue has been the appropriateness of the reduced form in single word utterances. So usually these reduction frequencies, how often is center produced as center, is measured in fluent spontaneous speech. However, the stimuli in lexical decision tasks are usually carefully produced single word utterances. So there's a bit of a mismatch in the context of how these reduction likelihoods are calculated for the experiment. This brings us to the current case, a case of German words which end on en or actually phonetically in schwa. In an earlier experiment, we had already noticed that even in single word utterances, they can occur in a reduced form. So if you take the German word to have, haben, with the en at the end, that's a full form. The typical form would be haben, and there's even a more strongly reduced form, which is ham. Now, to go beyond intuition, first I looked at the Thiel corpus to look at how often these forms occur for all words ending on en, not just haben, and also see whether there's a difference between read and spontaneous speech so that we can say what actually is the canonical form. And indeed, as I suspected, the form haben with no schwa but a nasal and stop and a nasal is the most likely form. But we see apparently the full form is more likely, more prominent in read speech, so we should call this the canonical form. Now this brings me to my first two experiments. The aim was to go for 64 stimuli. Why? We'll get to that in a moment. I found 44 monomorphemic words. I added complex nouns and verbs that were more frequent than their simplex counterparts, and high frequency plurals, which were more high frequent than their counterparts. So these are words for which we can be quite confident that they're represented as such in the meta lexicon. They were used in a lexical decision task in two different experiments. In a phrase experiment where participants hear is X a word, so ist haben ein Wort, and they have to say yes or no, and the more classical version where they just hear haben. Why these two different experiments? Well, there is this issue whether the reduction is more likely in a full phrase than in a single word utterance. The stimulus generation was done with a diphone synthesizer, the good old umbrella. And the reason to do so was that excludes any impact of human bias on the selection of materials. So if you read a paper on spoken word recognition, quite often you will read something like the targets were recorded multiple times and the best recording was chosen. Now, I'm in this business now for 2 decades, and it still bugs me because till this day, I haven't seen one replicable way of saying what the best recording is. So to me, that's actually a huge researcher degree of freedom. And as we move to openness, reproducibility, that was an issue. However, it comes with the downside that the stimulus quality is limited. And here we see examples. This is the German word erlauben. This is how it sounds with a diphone synthesizer, with a full syllable, last syllable.
Erlauben.
Even if you don't know speech spectrograms, you can clearly see that there are like 2 different segments here, and this is a reduced form.
Erlauben.
So since here I'm saying maybe there is no canonical form advantage, that is, I'm fishing for a null effect, I should do a power analysis. I looked at some early lexical decision data from my own work and saw that the total residuals tend to be at 50,000. That might seem a lot, but it's simply the square of a single trial standard deviation of 220 milliseconds. Use typical participant item values from Priespert and Stevens on their paper on power, use typical random slopes. Assume 64 items, 48 participants. Actually, to balance the list, it was a bit more in the end. And assuming a 60 millisecond difference, which has been reported in this kind of field, we get a power of 1. If I set power to 0.8, like the standard, like reasonable chance to find an effect, we have a reasonable chance to find a 29 millisecond effect. Obviously, this was an online lexical decision task, and to kind of gamify that a bit, to make it more interesting, every 40 trials, participants got feedback over their average accuracy and latency over these last 40 trials, and the motivator, well, maybe you can do better in the next 40 trials. The aim was to be at least 80% correct, and there were actually 2 voices that consistently reduced or not, leading to 8 lists. Which speaker comes first in the experiment, which speaker reduces, which speaker uses full form, and which item to which star. The analysis strategy made use of linear mixed effect models or generalized ones for the accuracy, starting with a full group random effect structure. And in case of convergence failure, random slopes with a small standard deviations were taken out. Latencies were measured in milliseconds from the onset of the last syllable, log transformed, and rather than just using a fixed criterion to remove unusual RTs, I first calculated an intercept only model. That is, I predict the log RT based on participant. Is it a fast or slow participant? Is it a difficult or easy item? And cases with large residuals on this model were rejected. Now, here we see the results. This is for the sentence experiment. So this is like, ist schreiben ein Wort? And we see a reduced form advantage. Well, I gave this punchline away with my title, in that reduced forms have a higher accuracy than the full forms. The gray lines you see here are the individual participants. We also see numeric advantage in RT with quicker reactions to reduced forms, but this was not significant. Now, moving to the single word experiment. So here participants simply here schreiben. There was only one difference, that the final syllable was made slightly longer to emulate the typical utterance final lengthening, but for the rest, the stimuli are the same. And we see the same pattern. Higher accuracy and shorter latency for the reduced forms, but now the effect is significant for latency, but not for the accuracy. Now, if one focuses on to significance too much, as the field has been doing, you might say something like, oh, with sentences, there's only an effect to accuracy, but not latency. With single words, the pattern is vice versa, and now I would have to come up with some explanation why that is the case. But that's obviously premature, because I would have to show that the effects with sentences are different from the effects of words. And if I try that in a cross-experiment comparison, I find relatively robust effects of speaking style, so that accuracy is higher for reduced form than for full forms, and no clear indication that this would be different for the 2 experiments, and exactly the same result for the latencies, for the reaction times. So I could have stopped at this point in time, but I wanted to see, well, these forms are really, really highly frequent. So it's very unusual for a German speaker to say something like haben or schreiben. I wanted to see, can we attribute this to variant frequency? So I tested an unlikely reduced form. So if we take the German word for to run, laufen, laufen actually isn't that likely. And since it's somewhat simpler and the type of experiments didn't really matter so much, I used the single word experiment. Here to example again, the word here is Tropfen, drop.
Tropfen.
The full form, and you can hear and see 2 elements in the final syllable, and the reduced form with just 1 long nasal.
Tropfen.
However, the results look pretty familiar to us. We get a reduced form advantage, both in the accuracy and in the latencies, and this time it's significant in both cases. So what is going on here? Does this mean that variant-free PC doesn't play a role? Well, if you look at words such as laufen, we see that assimilation is unlikely, but schwa reduction actually is likely. So the most likely form of laufen actually is laufen in German. So I did a smaller experiment, just comparing laufen with an M and laufen with an N, and given that I have to overpronounce it to actually make the difference, it's maybe not a surprise that there were no difference in latency and accuracy. And this indicates that even for this assimilation, maybe there's something like which is called pre-lexical normalization of place assimilation, which I already had found for regressive place assimilation, but apparently it also works. Sorry, for regressive assimilation, I found it in 2003, and now we see it also for progressive place assimilation. So I had another look at the corpus and looked at items where the schwa is not that likely to be deleted. And this is a case for words which end on ren, like the German word to disturb, stören, for chen, so words like kochen, and words in which the last syllable is onsetless, or a word like to stand, stehen. In this case, schwa is present in roughly 30% of the cases, rather than only like 3 or 4% for the other ones. Now, I found 80 words with similar criteria, verbs, nouns, and high-frequency plurals, same fillers as before, 50 participants. And now we find, actually, for inaccuracy, we find the old canonical form advantage, and in the latencies, we find nothing. Now, at this point in time, we did a Posttouch analysis for the accuracy results, where we actually did find this canonical form advantage. Why did I do this? Well, in the previous experiments, random slope of speaking style over item, that is the item produced as full or reduced, wasn't very strong, and most of the times actually had to be deleted to reach convergence. But here, it was highly significant. So if I look at my 3 types of items, chen items, I did find an effect of reduction for kochen, but not for items like stören and drehen. Also, I shouldn't say it's not just the case that I find no effect here and an effect here and here. The interaction between this and this is actually significant. So I have some substantial thing to talk about here. And the difference is, if I hear something like kochen, as a German speaker, I know that sh and n is not a viable syllable coda. So there must be some reduced vowel here. So this means this item is more easily recoverable than these ones. And what this seems to indicate that part of that canonical form advantage, if it's found, is due, as for instance, Pitt et al. In 2011 suggested, is that with a reduced form, you've got a wider range of possible competitors. So a word like stören also has to compete with a couple of one-syllable words, while the full form stören would only have to compete with 2-syllable words. So I think I was very economical with my time because I'm already getting to the results overview. If we look at the ben and fen items, where schwa reduction is likely, and ren where it's not that likely, we see actually in a cross-experiment interaction, so that for these cases, there is a reduced form advantage, and here's a canonical form advantage. And we see in latencies, we see an effect here and no effect here. And again, the cross-experiment comparison shows that this is a real difference. Now, in the discussion, first to summarize, the results failed to show a canonical form advantage apart from the accuracy errors in experiment 3, and we have a good explanation for this. That is, there's actually an advantage for highly frequent reduced forms, which is moderated by reduction frequency, and it suggests that the canonical form advantage might not be there when the reduction is actually viable in a single word utterance. Now, an intertwined issue here is orthographic involvement in speech perception. Now, Ziegler and Ferrand suggested words with irregular grapheme-phoneme mappings slow down lexical decision for spoken words. So a word just such as yacht, where the written form is quite different from the spoken one, are recognized faster, are recognized slower, even in the auditory domain, because there's automatic activation of the written form, and that is difficult if that is inconsistent. Now, this has mostly focused when this inconsistency arises on the side of the written form, but it also has been applied to when the inconsistency arises on the spoken form due to a reduction. So, for instance, Renbohm and Kunine actually said this explains the canonical form advantage. However, orthographic consistency effects are otherwise not found when the inconsistency is due to speech reduction. So together with Eva Reinisch, we compared Maltese and English and the reduction of the glottal stop, which should also be quite interesting for gender-fair language, because now the glottal stop really is a full phoneme in German. And we looked at the costs of reducing it from the canonical form to the reduced form, and only in Maltese, we actually have a graphing for it. So the orthographic involvement predicted a larger effect here, but that wasn't the case. And that was essentially conceptually replicated by Fiban et al., who trained participants novel schwa-reduced words in French. So why is this consistency effect then found with spelling to sound consistency? And here I would suggest maybe it arises at the stimulus side. Stimuli in these experiments are read from lists, and speaker may be distracted by difficult to read consistent items. So the inconsistent items may actually be acoustically worse than the consistent ones. So here I would ask those who propose these effects to actually try to replicate these effects with a diphthong synthesizer, which is not influenced by grapheme to phoneme consistencies. So my conclusions are reduced form advantages observed when the reduction is viable in a single word utterance. Getting back to Burki et al. And their question whether that effect is myth or reality, I clearly say it's a myth. And I would say this argues against automatic recruitment of written forms in spoken word recognition.